Hi everyone, this is Ranjit, and today I'm starting a new video series. This is going to be a series of tutorial videos on various computational geometry algorithms. Now, I made some of these videos last year. I made a couple videos on a couple different algorithms, but I stopped doing it after that. So I decided to get back into it and actually make a series of videos and try to, in the process, try to up the quality of my videos. So this time I'm starting out with a slightly bigger picture in mind. This is going to be, we're going to go through not one, but like several algorithms, and we're going to add all these algorithms to a single library of computational geometry algorithms. And we're going to develop this library, and I'm going to explain what I'm doing through the process of this development. And in the end, this library will be on GitHub, open for anybody that needs something like this. And if somebody wants to learn how to write these algorithms, they can do that by watching the videos. So that's the basic vision. And yeah, I have lots of different ideas in mind. To begin with, one of the first videos that I want to start with is convex hull algorithm in 3D. I also want to do R trees and other spatial search trees, Delaunay triangulations, and I have lots of other ideas in mind. So this is going to be a library with lots of different algorithms. And the language of choice that I'm going to be using throughout this series is C++. The reasons for that are performance, and I also wanted to really improve and brush up my C++ skills. So I think it's a good practice for me, and yeah, I just like writing code in C++ right now. So that's the language I'm choosing. And for visualizing the geometry and checking the results of our algorithm, I'm going to be using Rhino because it's really easy. You can just connect DLL, load a DLL into Rhino, call some functions, visualize the geometry. Well, more specifically, I'm going to be using Grasshopper to visualize the geometry. And beyond that, not just looking at the geometry, you can change the input values and test your algorithms and see how robust the algorithm is in Grasshopper. So I'm going to be using that. I've considered, briefly I considered making some sort of C++ based graphics pipeline, but I decided it would be too much work, and that's not really what this series is about. So I'm going to focus on just the computational geometry algorithms. So right now we're in the blank starting screen of Visual Studio. I'm using Visual Studio 2019 community version. And in fact, before we create any project or solution, let's jump to GitHub and create a new repository where we're going to keep all this code throughout this series. So I'm going to call this library of geometry algorithms GeomAlgoLib. So it stands for Geometry Algorithm Library. So I'm going to write a basic description. I'll add more meaningful content to the README file later, but for now that'll do. It's going to be public, and yeah, I do want to initialize a repository with README. I don't want Git Ignore. I'll add that later because we're going to be creating our project in Visual Studio, and Visual Studio creates a bunch of different files, and yeah, we're going to want to add a proper Git Ignore later. License, I'll add a license later. Let's skip that for now. So we're going to create this repository, and let's get that URL. And I am now in the terminal on my machine, and I'm going to clone this freshly created repo. And there we have it. So now let's jump back into Visual Studio, click on File, New Project. So like I said, we're going to be writing these algorithms in C++. So yeah, let's create a dynamic link library. Let's give this project the same name as the repository itself, but I will follow the C++ style and use snake case. But for the solution, I will use Pascal case. And I want my, okay, so we want to save the project to this path here, where into our newly created Git repository. So let's click create. All right, it took a second, and then now we have it. If we go into our folder, just open it up in Explorer, you see we have our README from before, but we also have this GeomAlgoLib folder, our solution file, and we have our C++ project folder here. So I don't really like how this particular folder layout, so I'm going to quit Visual Studio for a second. I'm going to move these files outside. I just don't want another nested level, like another nested folder inside my repository. So that is fine. And now, next thing we want to do before we open up Visual Studio again is to get a Git Ignore. So for our Git Ignore, like I said, Visual Studio is going to be generating a bunch of different files, and we don't want to be committing all those files to our repository. It's just a bunch of junk that we don't really need, and Visual Studio will recreate them anyway if you pull the repo onto a new computer and open the solution file. So we are going to have to ignore all those files, and for that I'm using this particular Git Ignore file that's available in this repository. I'll put the link in the description so you can also find it if you're interested. So I'm going to click on edit just so that I have an easier time copying all the text. I'm just going to click Control A and copy everything, and I don't want to actually edit the file, so I'm going to click on cancel, and let's go back in and create a new file. Let's call it .gitignore. Let's open that file up to put the copied text in. So I just put these two hashtags in there. Okay, looks like we pasted everything. Let's save the file, close it, and okay, so now we're ready to jump back into Visual Studio. So let's start up our solution. Okay, so in fact I have a multi-screen window layout going on, so for the sake of this video let me switch to a single screen layout so that you can see what's going on. Okay, there we have it. So this is our newly created C++ project, and if we go into our Team Explorer and look at changes, these are our newly created files. As you can see, because we added the Git Ignore file, it doesn't detect all the junk that Visual Studio creates. So now this is where all our algorithms are going to reside. But like I said, we're going to actually test these algorithms in Rhino. So we need something that can connect our C++ algorithms to Rhino. And we're going to do that using a .NET DLL that will be loaded into a Grasshopper component, and that .NET DLL will in turn call the algorithms in our C++ binary. So it's going to use pinvoke to do that. So let's go ahead and set that up too. So add new project, and this time we're going to select class library .NET framework. In fact, these two are the types of projects that I use frequently, so that's why they show up in recent project templates. If you can't see them there, you can search for them here and they should show up in the list on the right side. But I have them here, so I'm just going to select class library .NET Framework, click on next. And because this is sort of an interface that connects our library of algorithms to Rhino, I'm going to call it Rhino interface. And I'm going to use the .NET style Pascal case, and location looks good. 4.7.2 is the framework that we want to target. And that's it. We have a C# project with an empty class initialized. So because this will be loaded into Rhino, and this .NET project is what is responsible for actually creating Rhino geometry, we're going to need to add some dependencies. So we're going to add them as NuGet packages. So I just right-clicked on the project and clicked on Manage NuGet Packages, and that opened up this NuGet window. And I'm going to go into Browse and search for Rhino Common. As you can see, it shows up in my recent searches. And we're going to be using Grasshopper to do the actual testing, but we don't actually need to install the Grasshopper NuGet package. We just need the Rhino NuGet package so that we have access to the Rhino geometry types, and then we can take the results of our algorithms and convert them into Rhino geometry and, have them rendered in the viewport. So I'm just going to click install, agree to a bunch of things, and yep, if you go into references, now you have Rhino Common and Rhino UI, and in the code you can do using rhino.geometry, and now you have access to types like point 3D and so on, which are inside rhino.geometry namespace. So that is ready. So this video is essentially a setup video. I just wanted to set everything up before I actually start writing the first algorithm, which is probably going to be the next video. But yeah, so it looks like we're almost done setting it up. We're going to use pinvoke, so we're going to have to do a couple more things to get the pinvoke working correctly. Okay, so if I right-click on our C++ project and click on build, it's going to build, and if I click on right-click on the project again and click on open folder in File Explorer, we are in our C++ project folder, and it's going to build the final binaries to, if you are right in our solution folder, you are going to see a debug file, and so there is our DLL, GeomAlgoLib.dll. So I'm not really happy with this build path. I want it to look a little bit different, so I'm going to delete the debug folder, and I'm going to go into the properties of the C++ project. And so in the properties we have this, under configuration properties we have general, and under general properties on the right side we have output directory. So okay, there's one more thing we need to change before we can change this. I don't want to build for x86, I want to build for x64, and I don't even need anything other than x64, so I'm actually going to go inside my configuration manager and delete the other configurations. So I'm going to click on edit here, select any CPU, remove, select x86, remove, and I'm going to do the same inside for each of my projects. So edit, select on Win32 and remove. And for Rhino interface, it actually only has any CPU. So I'm going to click on, I'm going to have to click on new, create a new platform, copy settings from any CPU, and click OK. And click on edit, then select any CPU and click on remove. So now everything is just x64. And that's what we want. So now that we have that, let's go into the properties of our C++ project. And now you can see the output path is a little bit different from what it was before. So now it is putting our binaries in solution directory, platform, and configuration. Platform is x64. That's what we changed it to. So that's fine. I'm not really, I don't really want to change that. I'm happy with that path. But what I want is the Rhino DLL to know where the C++ DLL is so that it can copy the C++ DLL into its own target path. So we're going to go inside the Rhino interface project properties, and we're going to go in build events, and in post build events we're going to add some lines to our build script. So let's open up macros here so that we see what our paths are pointing at. So we're going to just copy what we have, the binary that we built from our C++, and it's going to be in our solution directory, and it's going to be the next level folder was platform name, and it's going to be configuration name. So as you can see, the solution directory has a trailing backslash, but the platform doesn't, so we're going to have to add that here. And the configuration name also doesn't have that, so we're going to also add that. And we have to copy all the DLLs. I mean, we could also copy just the one DLL, but we might as well just copy all the DLLs. That's fine. And we're going to copy them to our target directory. So that's our macro, which means whenever we build the C# Rhino interface project, it's going to copy the C++ DLL, so it's going to have the latest version of it. Well, not actually, because it's going to copy whatever is just there, right? It doesn't have to be the latest version. So if we build the Rhino interface project, we want that to automatically build the C++ project. So to accomplish that, we're going to right click on the Rhino interface project, click on build dependencies, and click on project dependencies, and we're going to select GeomAlgoLib. And this doesn't really make an actual connection between these two projects. All it does is just tell Visual Studio that whenever you build this, you're going to also have to build the other one, because I told you that it's a dependency. That's all that means. So now that we did that, if we build the Rhino interface, it should also build that. But before we test that, there's one more thing I want to do. So by default, when we build this Rhino interface project, the paths are different for debug and release configurations. And because we're going to be using Grasshopper to do the testing, it's much more convenient for us if we can build both release and debug configurations to the same path. It's not going to matter. We're not going to be actually taking advantage of two different paths. So what I'm going to do is go into the project properties and go to the build tab. Make sure in the configuration dropdown I have all configurations selected. Okay, let me just go back to debug and copy this path. So I have all configurations selected, and I'm going to just paste the path. It's the same path as before, except I removed the configuration name from the end. So both configurations will go to the same place, and because the binaries will have the same name, the files will actually be overwritten. So now that that's all set up, if we build this, okay, let's go to our target directory. So this is our Rhino interface, which is what we will be loading into Rhino or Grasshopper. Let's clean up these two folders. We don't really need them anymore. In fact, we should also clean up these folders because we don't need them. And now let's build and see if everything... So as you can see, as soon as I built the Rhino interface, it already started building the C++ project because we set it as a dependency. And now in the target directory of the Rhino interface project, we have the Rhino interface.dll and our C++ DLL. So at runtime, if we load just this into Grasshopper and use pinvoke, it's going to just find the C++ DLL sitting right there, and it's going to load and run the algorithms. So that actually finishes our setup, which this is all we needed to do as part of the initial setup. There are a couple other things that we also need to do on the Rhino side. We have to create a C# component and load this Rhino interface DLL into this C# component, and that's how we're going to actually connect our algorithms to Rhino, but I think I will do that in the next video when we actually start writing the algorithms. So that's it for this video. I'm really excited to start this series. I do have a long list of algorithms in mind that I want to go through in this series and add to our C++ AlgoLib, but if I can also take requests. If anybody wants to see a tutorial on a specific algorithm, let me know in the comments, and I'll try to make a tutorial about it. Hope you liked it, and hope you are also excited like me for this video series, and thanks for watching the video. Bye.